It is my pleasure to introduce our seminar speaker today, Dr. Sjoden from the Air Force Technical Applications Center, where he is the Defense Intelligence Senior Leader and the Chief Scientist there at Patrick Air Force Base. He is also the Senior Technical Advisor for AFTAC's 1,000-member center, providing technical analysis to detect, confirm, characterize, and attribute weapons of mass destruction activity. He leads the interagency community and integration for nonproliferation research and development and provides technical support to senior U.S. government policymakers, joint operational warfighters, acquisition and defense programs. He was previously a professor of nuclear engineering and the laboratory director at Georgia Institute of Technology and the University of Florida. Today he is going to be speaking about the AFTAC mission, where he'll present a talk about the importance of nuclear nonproliferation, the adherence to nuclear test ban treaties, and the AFTAC mission to monitor those treaties for the U.S. in cooperation with international monitoring agencies, including the IAEA and the Comprehensive Test Ban Treaty Organization.
Thank you very much. Dr. Hayes, I appreciate the invite and the chance to come and talk to you. You are the next generation. You probably haven't thought very much about that. You're just trying to get your courses done and get your homework done and get your program to run. But you're the next generation of nuclear engineering in this country. And so we definitely need you to be at your best possible footing coming out of school, extremely effective on the job. Because that's what we're counting on. You're the next generation, you're the future. So you probably, when I was sitting in your chair back in either, whether you're undergrad or graduate school, you really never thought about that. You're just too worried about the day-to-day. But the big picture is, you've got a long history to fulfill. And so make the most out of your learning today while you're in class. If there's something that you're not quite sure about, you should take the time to investigate that and run that through and make sure you're crystal clear on it. If there's a passion you have for any particular research, you should definitely explore that. It's never too early or too late to just jump in and look at it. Today I'm going to talk to you about the AFTAC mission, the Air Force Technical Applications Center. That's kind of a mouthful. I've been associated with AFTAC a long time. I served in the military for 20 years. I retired back in 2004 from the military as an officer. I was a career nuclear officer. And then I went into academia for 10 years and did 10 years of academia, nuclear engineering. And then for the last almost 5 years, I've been back as the chief scientist back here at AFTAC. AFTAC basically is the entity that monitors, as Dr. Hayes said, basically the treaties that monitor for nuclear testing. So we're responsible. We're the only entity in the U.S. government that does that. It's complicated as to how that fell on the Air Force. I'll talk about that a little bit. You might think, well, how does the Air Force do that? I thought the Air Force was, flying, fighting, winning. The official mission of the Air Force is to fly, fight, and win. If you look that up on the internet, that's what you'll find. But the Air Force has a very, very broad and deep science and technology element. I just came from a meeting that was held by the Air Force chief scientist. He's kind of my boss of chief scientists, because there are all these chief scientists at all these different Air Force organizations, and the chief scientist of the Air Force, his name's Dr. Rich Joseph, had a meeting of all his chief scientists at Oak Ridge, and we went through some facilities at Oak Ridge just earlier in the week. So I'm coming right from that meeting to this, because I told Dr. Joseph, I signed up to come do a seminar, and I definitely have to do it because it's an important thing to talk to you, the next generation. So where are we? We're our headquarters. We have a number of worldwide locations, and we work with international entities like the IAEA and the Comprehensive Test Ban Treaty Organization. But we're located in a very difficult location, Patrick Air Force Base, right below Cocoa Beach, Florida. Lots of fun beach activities there if you're a beach person. I'm not so much of a beach person. You get sand all over your car, and things like that. So I don't really spend a lot, and I burn like a crisp out on the beach, so I don't really go to the beach very much. But lots of folks do, and this is our building on Patrick Air Force Base. You can see it's a bright sunny day. Most of the days are bright sunny days. So anyway, that's a little bit idea where we are. Kennedy Space Center is just north of us, and from my office window, which overlooks, this is my office right there, overlooks Cocoa Beach and the surrounding area, and I have a really nice view of the Atlantic Ocean, and I also have a really nice view of Cape Canaveral. I can watch all the rockets launch whenever they launch. So when SpaceX launches their launch, I get to see, just sitting at my desk, I can watch the rockets launch, so it's kind of cool. They kind of are like, people are like, oh, they're going to launch a rocket. And I'm like, yeah, I've seen a lot of those. So it's a pretty interesting and unique location. Perhaps I need to pay more attention to those rocket launches because, maybe someday I won't always be there to see them, and they're not that routine of an event. But for me, right now, they're pretty routine. It is exciting to see that, especially at nighttime when you see that the launch go off at night. It's really incredible to see. So that's a little bit about where we are. We're about 1,000 people, 50% military, 50% civilian. Our civilian workforce generally has a number of degrees, but we have a pretty large contingent of nuclear engineers because we deal with basically nuclear issues with monitoring the Limited Test Ban Treaty and other treaties. So I wanted to talk a little bit about nuclear weapons. You probably don't talk much about nuclear weapons in your daily routine, and that's, well, probably by design, because most of the uses what you're trying to do are to prevent these things from going off, or to do research in detection of nuclear materials, or new reactor designs, new power sources, energy storage, new materials, material science, materials analysis, in general energy production in a controlled way. But nuclear weapons are extremely destructive. We don't test these things in the atmosphere anymore. We used to do a lot of them. The U.S. tested over 1,000 weapons total. The Russians tested a pretty good amount as well. And when these things go off, this happens to be Operation Crossroads, the Baker test. It was done out in Bikini Atoll. It was a 21 kiloton bomb, roughly 100 feet underwater. And its effects are pretty dramatic. What you see here, this object here is a battleship getting sucked up into the column. So yeah, this is staggering amount of energy released in a very short time. Actually, the energy is released in a very short time, and then what happens next is what you're seeing here. So these things are extremely destructive, and people somewhat, I believe, have lost their appreciation for how destructive these weapons are because, well, you just don't see this that often. It's hard to imagine what would happen. But let me give you a little perspective. The United States Air Force, we have some of the best airplanes in the world. One of them is the B-2 bomber. The enormous energy released from a nuclear weapon is many, many times typically more than what you can haul in a B-2 bomber. You think, well, B-2 bomber, that's pretty stout weapon system, and it is. Single B-2 bomber, 172 feet wingspan by 69 feet long. That's a picture of one up there. It'll hold 80 500-pound bombs. Is that a lot? Would you want 80 500-pound bombs going off on you? Probably not. So that's one bomber holding 40,000 pounds of bombs. We talk about, and you hear in the strategic arms talks about kilotons of energy being released, the yield of X number of kilotons. Well, I want you to think, that's a huge amount of energy. Think about the B-2 bomber and these 40,000 pounds of bombs. Let's talk about 1/10 of a kiloton, 100 tons. 100 tons is 220,000 pounds of bombs, or 440 bombs delivered by 5.5 B-2 bombers on one spot, instantaneously. That's for 100 tons. That amount will destroy 8 city blocks in a single instant. So if you look at the campus out here and think blocks for 100 tons, which is 1/10 of a kiloton. Wow, that's just an enormous impact. You'll have an Ld50 dose. Anybody know what Ld50 is? You should know what Ld50, right? Lethal dose to 50% of the population, out to 8 miles with 1/10 of a kiloton. Okay. So contaminating basically more than 100 square miles effectively. And this is a very small nuclear yield. Most of the yields on the test I just showed you, 21 kilotons. We're talking here, these effects are for 1/10 of a kiloton. So the amount of power, the amount of lethality of nuclear weapons is extremely, probably underappreciated by most people. I've been a nuclear engineer for 34 years, working in some capacity. I have a hard time getting my head around this amount of energy being released and the amount of destruction this can cause. It's hard for me to fathom that. And I'm very familiar with this. I live this every day. So I can't imagine the average person out in America would even, have a good concept of what this means. But this is why we had the Cold War and ramping up, and things were in a very scary time for the United States, mostly against Russia, to scale up the nuclear arms race, and why it was a very scary time for folks. And probably those kids getting under the desk, you've probably seen those old movies where they have air raid drills and they tell the kids, get under your school desk. If you're anywhere near one of these things, that's not going to matter. So the other issue is when one of these things goes off, what happens? You get this energy pill going off. Now this one's in water, but what's happening there? Do you have a truck axle with a VIN number on it? No, you have plasma, right? Everything's an ionized gas out to a certain amount, depending on a lot of physics, a lot of what goes into it. But so to even figure this out, you have to have a very sophisticated system of protocols in place for technical evaluation to be able to determine what that was, what that event was, and possibly who did it.
So if we look to this and we say that kiloton, the can destroy 8 city blocks is what can be classified as tactical nuclear weapon.
That is a current question that's under debate, is what really does tactical mean when you say nuclear weapon?
Yes.
Because it's very hard to describe. What's your definition of tactical? Well, if you're maybe in Star Wars and you're orbiting over the planet, and maybe that's easier to classify. Now you think about the Star Wars movies, where they had the Death Star coming in and blowing up the entire planet. How much energy was that? That's a huge amount of energy. Probably not enough from that little ray they fire, And by the way, there is no noise in space, right? You don't hear the ship going. Okay, so anyway, but great question. What constitutes tactical versus strategic? This is a question. So nuclear weapons pose the greatest potential for the greatest amount of fatalities. when you're talking, you hear the expression nuke, chem, bio as weapons of mass destruction. Nuclear weapons are more than 100 times more devastating per delivery weapon than any chem bio attack that you could have. Now, certainly, somebody attacks you with a chemical weapon. We've seen in London, right, recently, had a couple of folks in London get attacked with some chemical agents, and various countries were blamed for that. There have been bio attacks by various terrorist groups and other folks, but you're not talking about 100,000 or 500,000 people in a single instant. Whereas with nuclear weapons, that is in fact what you're talking about. The nuclear weapons are the only weapons that can bring what is called the point of no return for any single nation. What is the point of no return? That is, society as we know it today ceases to function and will not come back. Nuclear weapons are the only ones that can actually cause that. Chem and bio, they can create havoc. They can certainly cause a lot of death and illness and other things. But you're not going to totally destroy life as we know it, whereas nuclear weapons can indeed, depending on the scale, do that. So it's very important that we avoid having these things deployed because we'll have damage so extensive that no recovery is possible. So most of the damage assessments, by the way, are postured for war planning based on the Cold War. They do not account for nationwide hospital burn unit capacity. By the way, you'd probably consume the entire burn unit capacity of the United States with, perhaps even a single attack because of the number of casualties you'll have. Long-term environmental effects and economic chaos will certainly happen. Look at what happens to the stock market daily when someone gets arrested. The market will drop 300-400 points. That happened today, right? So, magnitude events like this is why the job of treaty monitoring, making sure people adhere to the treaties, making sure there is a viable non-proliferation regime, making sure there's an IAEA and a comprehensive test ban treaty organization is very important because this is an important mission to maintain. And also nuclear forensics, our ability to process what happens when you get this going on in any given city. Now, where are most of the tests conducted in the past? Pardon me? Islands. Way out where? Nobody lives there, right? Well, very few people live there. Or some people did. Some Japanese fishermen did. Or places in the United States called Nevada Test Site. Now it's Nevada National Nuclear Security Site. But it was Nevada Test Site where we had Nevada Proving Grounds, where also people didn't live so much. So you test these in remote places. Well, where we're talking deployment is if this happens in a city where you actually have real buildings and real people and real life and infrastructure, and the effects are dramatic. And some tests were run back in the 50s to look at this on a limited scale to try to assess what would happen. But again, treaty monitoring and maintaining the world's posture to fight against the adoption of weapons programs is an important goal. So our global mission is to basically run a sensor network across the globe where we're hooked into the international monitoring system, which goes and has a headquarters at the Comprehensive Test Ban Treaty Organization on the UN compound in Vienna, Austria. So it's a tough job. Somebody's got to fly to Vienna a couple times a year, and I get to do that. and they have really nice wine, and they have an interesting opera house. If you've never seen the opera house in Vienna, it's quite impressive. Anyway, we run the Air Forces. The Air Force has been put in charge of this, and I'll talk a little bit more about that. And we're in charge of basically monitoring that network to make sure people are adhering to not violating the test ban treaties. And so it's a 24/7 job. I have people in an ops center watching the world 24/7. Even I go in on Christmas Day and I bring food to our crew on Christmas Day because they're there on Christmas Day and Christmas night and all the other holidays. I went in on Thanksgiving. We brought them a turkey dinner because, well, we have people working 24/7. We have an innovation lab and other things, and we have lots of folks with lots of talent to focus on this problem. Most of the jobs in the civilian sector pay pretty well. Florida is fairly low cost. You generally need to qualify for the jobs a master's degree. You could do it with a bachelor's degree, but it's harder. The government hiring system is a bit onerous when they want lots of advanced education. So we have a number of doctoral folks and a lot of master's degree folks. Bachelor's some, but it's harder to be honest with you, it's harder to get hired with the master's because the government has some strict requirements. So where did this start? Well, this guy, President Eisenhower. By the way, when Eisenhower retired as president, he went on to play a lot of golf. And his wish was, when they called him President Eisenhower, he said, no, I want to be referred to as General Eisenhower. Because he loved being the military guy, and he was the president. But he preferred the title of general, and that's how he basically left us. He actually talked to President Kennedy and got his title changed back to general rather than former president. Anyway, he was a visionary. He did a lot of good things for the United States in addition to winning World War II. He decided that the Army Air Force, which the Air Force used to be called the Army Air Force, is charged with the overall responsibility to detect atomic explosions anywhere in the world. And he made this decision a couple days before the Air Force was actually born. So our organization is actually older. Our overall mission is older than the Air Force by a couple of days. But we are an Air Force organization. Ike, as he was called, did a lot of things, a lot of good things. He was a real visionary. Interesting fact about him, if you read a book about Eisenhower, you'll learn about all the cool things he did. But one of the interesting metrics I found was that his highest approval rating was 80% during his tenure. Now that sounds like a really high approval rating by today's standards, right? For presidents. And I won't try to comment on anything other than the fact that he said, well, you know what this shows is 1 out of 10 people are always going to be unhappy. And that may be true. Or 1 to 2 people out of 10. And technically, if that's 80%, that's what? 1 out of 5. So if you have 5 graduate students, faculty, 1 of them is probably going to be unhappy. The other 4 will be happy at any one time. But I think that's a true statement, though. Out of a I have 3 kids. 1 of them usually was unhappy about something. They're mostly grown up now, all in or out of college, but I can tell you that's mostly true. But anyway, the AFTAC mission is to operate and maintain the United States Atomic Energy Detection System, and using scientific and technical means to obtain and evaluate data, nuclear treaty monitoring and compliance of foreign government nations. So if you look into these treaties, and I'll talk a little bit more about them, they have some rules of compliance. So if you're a signatory, you agree to comply. And we also do a great amount of research and development to operationalize new techniques to help us do this job. So the various treaties started out with John F. Kennedy. Is one of the last things that John F. Kennedy did before he was unfortunately assassinated on November 22nd, 1963. He managed to get the Limited Test-Ban Treaty signed, and there's a picture up there showing the signing of the treaty. And that basically says that you can't do anything but underground testing, because what was happening prior to 1963 was a number of nuclear weapons were being tested in the atmosphere, and it was placing a huge radioactive burden of fallout into the atmosphere, of which, if you go out and sample in the upper atmosphere, you can find plutonium particles, very small plutonium particles from the tests conducted in the 1950s. Now, the amount goes down every year, but there is effluent in the atmosphere that contributes to the global background, in addition to cesium and other things. Now, cesium, takes a long time to work its way out of the environment because of long half-life. Cesium-137. Then, about roughly a little more than 10 years later, we had the Threshold Test Ban Treaty that said, okay, you can have these tests, but they need to be limited to 150 kilotons. That's still, as we discussed, that is an enormous amount of energy. A kiloton is about 4 times 10 to the 12th joules. So it's a huge amount of energy. So, and then there was the Peaceful Nuclear Explosion Treaty, because we said, well, there's got to be a way we can use these things to carve out dams and cut channels and other things and do some things. And so we had this program called the Ploughshare program. And this is a picture of the Ploughshare program Sedan nuclear test. Anybody been out to Nevada test site? I know you folks have. And you see the Sedan crater is one of the stops. And you go and you see this monster crater. And it was a nuclear test to show that, hey, you could use this maybe for mining or these kinds of things. The problem is it created a lot of residual radioactivity. So they decided, that may not be such a good idea. But you could still use them for that if you really wanted to live with the radioactivity, but that's under the Peaceful Nuclear Explosion. And then we entered the era in 96. They decided we really need to ban testing. We really don't want to promote these weapons. The arms race, is slowing down. We had the Russians go through, it used to be the Soviet Union, the breakup of the Soviet Union, all those things playing into at the end of the Cold War. We said, okay, comprehensive nuclear test ban treaty, we're going to ban all nuclear explosions for military or civilian purposes, period. Yeah.
What are the consequences if somebody tests one here?
Well, they're not going to be a signatory of the CTBT. And or they may try to pull out. If they did sign, they want to pull out of the CTBT. One of the challenges we have right now is that President Clinton signed the treaty, but Congress did not ratify it, which means that officially, we officially participate in the CTBT. This is a challenge for us. It's a diplomatic challenge for the State Department because we're not listed as an official full signatory because Congress didn't ratify it. So we cooperate and we implement it as if it were in force, but it's not officially in force for the United States government. Place a position where we assume it's what we've got to do until we're told otherwise, and so we do operate as if it's in force for the U.S. because the president did sign it. However, Congress has officially not ratified it. So the truth is, it's complicated. It has created some difficulties diplomatically for the United States because of the fact that other countries will point and say, well, you didn't ratify, and you should have. So the reasons Congress did at the time was because technology wasn't at a level where they felt that they reasonably ratify the treaty and uphold the tenets of the treaty. The other question that came out of CTBT was, what is zero? What does zero mean? What nuclear yield is zero? Is it nuclear yield we can measure? And that gets into some very complicated questions. You can see here the timeline. The time I came to AFTAC was right here, and I didn't show the timeline extending past 2015. Of course, we've had quite a bit of, let's just say, quite a bit of activity in North Korea since then that has posed some challenges. We monitor for nuclear testing, and when we see something like what's been going on in North Korea, we report that up to the chain to our national authorities. They certainly have kept us busy, but you see all the different nuclear powers, and India and Pakistan are always trying to top each other, and that's probably potentially a problem. But they are also nuclear powers, so it's a complicated environment we live in. But this is the evolution of the testing. So for organization, just to give you an idea of what we're about, I won't spend a lot of time on this because I know boring wiring diagrams aren't usually that popular. But I report to the commander. I'm the chief scientist. We have an infrastructure of folks. We have a number of squadrons basically dedicated to different aspects of the mission: seismic, hydroacoustic, satellites, and other things. We have a lot of different sensors that we apply to the problem. And of course, working with the international regime there, IAEA, CTBTO. I already talked, in fact, we have an operations floor that's 24/7. We have field maintenance where we've got to go to places like Antarctica and far reaches of the world to sometimes fix our equipment. Sometimes we had these bears. Someone had the brilliant idea of making these cables with a honey-based insulation. So we had bears in Alaska coming and chewing through our cables. And we can do a lot of remote maintenance, but it's very hard to do remote maintenance when someone bites through a cable. You have to then send someone all the way out there, and then you got to replace the whole cable. It's really not that fun. So we have a lot of things like that with wildlife and issues with that in various monitoring stations. And of course, we host all the different international governments, and we help train folks on new seismometers and other things that we use to monitor. And we host folks and train them up on how to do regional monitoring on their networks. And so it's a very busy time for us most of the time. So we have basically nuclear explosion detection is one of our key issues. And we have atmosphere and space platforms, geophysics. We have an airborne WC-135. We're getting a couple more of those with improved avionics, because the ones we have are fairly old, and the Air Force has agreed to replace them, so we're very happy about that. We have best detector halls in the world. I think we have like 30-something HBGE detectors in one of our labs, and they're all maintained with the most modern cryostats and energy calibration stuff, because we have to maintain all this stuff to be able to do the mission. So one of our missions in applying this, in addition to the treaty monitoring and trying to make the world safer with research and development, is if we have a nuclear event in a city, AFTAC is going to be one of the first places that goes into that area. We're responsible for doing nuclear forensics on that event for the US government. So we'll go in and we'll profile that event and basically work with the FBI and what's called the FIRMAC and others to be able to process that scene, and if we ever have to do this. Hopefully we don't, because as we talked about, if you have one of these events, you're talking about massive casualties, because nuclear power in the weapon form is an immense amount of energy released in a very short time with a huge impact. So we have airborne and ground sample collection, sample analysis. We have a whole thing where we exercise this routinely. I'm the guy that gets to come in and make the final technical evaluation that goes to the president. So we get to exercise that every 2 years, roughly. Our next exercise is coming up. So we do this on a regular basis, so we have a battle rhythm. And we do it usually for a period of days, and the next one will be 24/7. So I'll plan on sleeping in my office for a few days at a time. So anyway, it's kind of a sobering mission. I hope we never have to do this. We do exercise, but I hope we never actually have to do it. But it's something that we have to plan for. We also have other missions where we actually have a couple of ships and we do radar collection and profiling. So our overall, we detect, locate, identify, and characterize nuclear explosives, detect and evaluate nuclear materials. Oh, one thing I didn't mention is we're part of the network of analytical labs. So for the IAEA, when they send inspectors out, we have a lab system that we're part of the international consortium that helps the IAEA do its mission for monitoring and the additional protocols. So we do the analysis for the IAEA and report results back to them. We've helped them with administering the JCPOA. So we're part of the international consortium that helps out with that under the UN. And we also help prevent weird things from happening, like interdiction of nuclear materials with various governments that are trying to do that. And then we operate and sustain some radar systems. So with that, we have a whole team, lots of teams of folks all around the world working on various things to maintain equipment worldwide, to make sure the world is safer and better place. And we collaborate, if I didn't mention it, we collaborate with all of the national laboratories in the DOE system. So if you go to anybody at any of the national laboratories, just pick one and say, do you know about AFTAC? They generally, well, I would hope they would say yes. So that's all I have for you, and I would like to open it up for questions. Lately, I would say, because most, like in the case of North Korea, their tests have been underground, so it would be seismic. Of late, I think would be the most routine. So I've had to get. I'm a nuclear engineer. I taught a lot of reactor physics and radiation transport. My favorite topic. If you don't love it, embrace it. Okay, you'll need to eventually, right? But I've had to really appreciate geophysics. But let me say something. Nuclear engineering is an awesome major. Why do I say that? Because it trains you extremely well for any discipline. All the geophysics stuff is basically, think about it, solving a wave equation and understanding propagation of waves through the Earth's crust, and understanding the principal waves and the shear waves, primary waves and shear waves, and how those interact with the Earth, and the frequencies involved based on the speed of sound in materials, time distance of arrival, all these things. So I've had to become an expert in geophysics because, well, seismic is an important detection mode. So good question.
For the forensic response team, what is the assumption for the event that goes on? Say a one-off nuclear explosion, or the whole country gets swarmed by from it. What's the scope of the response team?
I'll have to think about what I can say. All options are on the table.
Okay.
We prepare for everything. But we do work with other DoD organizations to enable us to do the mission, because we have to do ground and air component. Because when a nuclear weapon goes off, you get material ejected, and you have refractory materials and volatile materials, and they played out at different times, and so they fractionate, and they come down at different spots, and it'll tell you something about what's going on there. And it affects dose rates and other things and consequence management. So there are a lot of complicated models that we run to try to help folks predict what's going to happen. So we do look at a lot of scenarios.
Again, about my initial question regarding tactical with point 1K, because if we wanted to really deploy all of these for some useful and peaceful uses, like what you mentioned, digging the canals or doing whatever, maybe we need to go all the way down to point 0.01 instead of point 1. But we will have some limitation because we have limitations within the critical mass.
I can't go into detail on that
I
one.
know.
But the problem is we're prohibited from detonating anything in the atmosphere under the treaty, Ld50. So we're not allowed to do it, even under, and they've said that they're no longer going to pursue plowshares. So we can't really do it. But that's a good question. I'm pretty much an expert in criticality, though. I understand that pretty well, but I don't want to answer your question.
So what does like a typical day look like? It's like an officer working in AFTAC.
A typical day. Well, a typical day would be maintaining. Depends on where you work. We have this whole multi-physics of sensors and data coming in, and we have naturally occurring events like earthquakes that we have to discriminate between them and maybe a nuclear explosion, especially if they have an earthquake on a place that traditionally was a nuclear test site. So we have to discriminate that and apply all the science we have and take a look at it. It's going to a national laboratory and looking at a new algorithm that they came up with for us to use and evaluating whether or not that's good and telling those folks, hey, here's what we could do if you could run this better or give us a better model. So they're actually developing some models for us to run on high performance computing, modeling the Earth's crust so we can figure out how do we do our job better. It's looking at all the phenomenologies and the physics. And so we have a lot of interesting physics problems to contend with challenges like lightning. You don't think much about lightning, but lightning comes down and strikes. It happens very rapidly, and it causes an RF signal, right? A radio frequency signal. And you'll get things that maybe you got to account for that lightning strike in your detection gear. You have to understand it. Okay, wait, that's a lightning strike. That doesn't, that's not a nuclear weapon going off. It's a lightning strike. So things like that.
Yeah, I'm not sure we ever defined for our students what attribution is in non-proliferation research. Could you explain that again?
Attribution in nuclear forensics is assessing the origin of that attack based on the forensic evidence available from the scene. Post-processing, back calculating and attributing that event, and figuring out basically who done it. And I think I can't say a whole lot more than I think we're pretty good at it. But because we do exercise that, and there's a lot of science that goes into that. Yeah, there's a lot of good science that goes into it. So keep studying hard. You got to be good at what you do.
This leads actually to the question about, research. Do you provide research opportunities?
We do. We mainly work through DOE and NSA, and they fund and they actually consortium work. They ask us about work funded at national laboratories that sponsor postdocs, and we also collaborate with them quite a bit. So most of it's funded between Department of Energy and DITRA, Defense. There are others. DARPA is another organization. Not so much NSF, because NSF doesn't really do nuclear too much. However, there have been some NSF grants when they relate to just fundamentals of seismology, fundamentals of elemental and particle physics. So NSF is not totally out of the picture, but it depends on what the it's more basic research. The research that we do research, but it tends to be after DOE delivers it at TRL 4 or 5, we bring that research to TRL 7. Okay, so actually this gives me a chance to talk a little bit about some things you need to be aware of to make yourself more marketable when you're out there. Technology readiness level, thank you for pointing that out. I'm so used to talking the lingo. So technology readiness level, TRL. What is TRL spans from 1 to 9. So TRL 1, 2, and 3 is developing the fundamental tools of a new method. Just the fundamental basic research demonstration. So that's 1, 2, and 3-ish. There's a gray area around TRL 3 where you can actually apply it to a real applied problem. So that's TRL 3, 4, and 5. So 3, 4, and 5, if you get to 5, that's really, it runs on a breadboard plugged in. There's lots of wires and circuits and everything's kind of messy, but it works. You've done a demonstration. TRL 6 is a field test of that item in the field in a very rough design. TRL 7 is a very fieldable, mature technology that works fundamentally in the field for a field operator. TRL 8 and 9 are very nice powder-coated cases with shiny knobs and a warranty and everything's great, and it has a full acquisition cycle, what's called a full acquisition cycle to TRL 9. So when we canvassed various folks in the national laboratories about what is it that you're looking for in a new hire from the university. And they said, we're looking for technical excellence. It's kind of the same things we're looking for in a new hire. Technical excellence, think on your feet, able to give a presentation clearly, and also have some amount of business acumen. Know how to write a cost proposal. Know how to write milestones and deliverables. It's a lot like being a university professor, right? Milestones and deliverables and a business work schedule, a work breakdown structure. Now, most folks coming right out of their degree in nuclear engineering probably haven't done a whole lot of that. I would encourage you to take a business course if you can take an elective, that covers a little bit of that. Not that you have to be an expert at business, but it's great for your job resume if you know something about project planning, milestones and deliverables, and execution, because that's what as a real engineer out there in the world, whether you're working for us or working for the national labs or working for Westinghouse or anyone else. And you have to do that as a professor. If you want to be a university professor, you got to write grants, and they have to have milestones, deliverables, and a cost schedule. That's the first thing you do, right? As a young professor, that's the first thing you're going to do. So take that opportunity. When I was in your shoes, I was like, I don't want to do that business stuff. Forget it. What a waste of time. I quickly learned that's not how the world works. So you do need that skill. It's an important skill. So take, if you can, not saying you have to, but if you can, try to work that into your curriculum. The other thing you need to know about in the nuclear world, most places in the nuclear world, you have to be able to maintain a security clearance. To do that, you have to have a very clean lifestyle. I will only say that the places that have legalized various things like marijuana are on a state level. The federal government doesn't recognize any of that. To them, it's all illegal. And it is not conducive to holding a security clearance. So make sure you live a very clean lifestyle if you're going to work in the nuclear business, because that's an important thing. So I probably don't need to elaborate more on that, but we've had some folks show up that said, gee, is that a problem? And I'm like, yes, it's a problem. So those are a couple things that I think I would like to make sure I pass on to you. That use your education time here. You have a very nice reactor. You have a very nice nuclear engineering program. You have some very talented faculty. If you have questions that you're not answering about technical issues that you have an interest in, make sure you find out before you leave so you can answer those questions, because they will come back and haunt you if you don't answer them now. You'll need to know them sooner or later. So I know everybody, I used to teach transport theory. People see that Boltzmann equation. Scary equation. What doesn't kill you makes you stronger. Embrace it. Okay? And know that we're watching 24/7 to make the world safer. We're working with the international community. We're trying to do our due diligence for the U.S. government. They're counting on us to do that. And we take the job very seriously because the consequences are very big if something does happen. And so we're doing our best to make the world as safe and happy as we can. So anyway, thanks very much for your time. Any other questions?
One more.
Oh, yes, sir.
About the communication with the international community. This is instantaneous, such that if any signal appeared and we know that it's coming from somewhere, is it immediately broadcasted for all other
It's on something called the International Monitoring Network. The headquarters is in Vienna, IAEA, at the International IAEA compound, but it's CTBTO maintains their data center there. And AFTAC maintains the U.S. part of the International Data Center. So we are the members that maintain that for the government. It is. Well, as fast as signals can propagate. That's right. Yes, sir. All right. Thank you. Okay. Thank you.